The WWII prison camp cooking trick that worked without fire. The survival hack the Nazis never stopped. No stove, no flame, no smoke, and yet food was cooked, behind barbed wire, under watchtowers, inside the most controlled prison camps of the Second World War. Men found a way to heat meals without lighting a fire. And somehow, the guards never truly stopped it. How? Inside German POW camps, especially Luftwaffe-run camps like Stalag Luft III, Allied prisoners faced brutal monotony. Rations were thin. Bread, turnip soup, watery potatoes, not enough calories, not enough warmth. But something unexpected happened. The Red Cross. Parcels began arriving, packed with powdered milk, chocolate, margarine, dried vegetables, canned meat. But there was a catch. You couldn't just light a fire in a barracks. Smoke drew attention. Open flames meant punishment, confiscation, solitary. So here's the question. If you're starving, if winter is creeping in, if your guards forbid fire, how do you cook? The answer wasn't obvious at first. It wasn't handed down by officers. It wasn't a military tactic. It was chemistry, specifically improvised resistance heating. Here's what the prisoners realized. Electricity was everywhere in the camp. Lights, speakers, occasional wiring lines running through the barracks, and electricity produces heat. If you can control the current, you can create heat without flame. The device they built became known as an immersion heater, and honestly, it was shockingly simple. Just two pieces of metal, often razor blades, a small bit of wood or cardboard separating them, wires, scavenged from radios, light fixtures, or whatever scrap they could find. The blades were attached to opposite wires, spaced just barely apart. Then, the whole contraption was submerged into a tin of water or soup. When connected to the electrical supply, the current passed through the water between the blades, and the water itself became the resistance. It heated up. Fast. No flame, no smoke, just a tin can quietly steaming in a bunk corner. Let's break it down. Electric current always looks for a path. Water, especially salty soup water, conducts electricity. When the two blades were placed close together but not touching, electricity jumped between them through the liquid. That resistance produced heat. It's the very same principle behind modern electric kettles. But you see, this was 1943, in a prison camp, built from scrap, and it worked. Prisoners could boil water for tea, heat powdered milk, cook dried vegetables, even create makeshift stews. It wasn't gourmet, but it was warm. And warmth in captivity is power. Now, here's where it gets dangerous, because this wasn't just clever, it was lethal. Improper spacing of the blades, they'd short-circuit, sparks, too much current, wires melted, hands wet while plugging it in, electrocution. There were burns, there were shocks, there were barracks-wide power outages, and yes, sometimes guards investigated. But here's the strange part. The Nazis never fully eliminated the practice. Why? German prisoner-of-war camps, especially those holding Western Allied airmen, operated under the scrutiny of the Geneva Convention. The guards knew, you see, that the war was being watched. If prisoners starved, word would spread. If treatment was brutal, retaliation might follow. So, a quiet line emerged. As long as prisoners weren't openly sabotaging, as long as fires weren't breaking out, some guards looked the other way. Not always, not kindly, but strategically. Because, morale management was part of camp control. A slightly better fed prisoner was less desperate, less rebellious, less likely to riot. But here's what makes this story bigger than food. The immersion heater became a symbol, not just of survival, of ingenuity. Prisoners of war formed cooking clubs. They shared Red Cross ingredients. They traded recipes. Men who had been engineers refined the designs. Those with electrical knowledge reduced risk. Camp kitchens, invisible ones, formed inside bunks. Imagine that. Inside a system designed to strip autonomy. They built their own utilities. There's something poetic here. The same physics that powered German infrastructure, powered prisoner survival, resistance heating, Ohm's law, voltage, current, conductivity. Textbook science turned into quiet rebellion. And it didn't stop there. Some prisoners used similar principles for improvised water distillation, sterilizing instruments, even heating metal tools for escape work. Electricity became their invisible flame. Technically, yes, they could have restricted wiring access, reduced voltage, conducted more searches, but, war is chaos. Camps were understaffed and resources were strained. The front lines demanded attention, and, many immersion heaters were dismantled in seconds if inspections came. Blades removed, wires hidden, tin returned to normal. Unless you caught them in the act, there was nothing to prove. Over time, designs improved. Blades were replaced with metal strips. Insulation added using cloth or paper, better spacing to prevent short circuits. It became a quiet technological evolution, not for profit, not for glory, for soup, for one hot meal in winter. Now, consider this for a moment. In captivity, routine is survival. Hot tea at night, warm milk before bed, shared stew in a hidden tin. These aren't luxuries, not by a long shot. They're anchors. They restore identity. They preserve dignity. They remind you, you're not just a number behind wire. You're still capable, still thinking, still adapting. So here's the unsettling thought. If prisoners could build functioning electric heaters from scrap, what else could they build? And, some did. Radios, forgery workshops, tunnel ventilation systems, the same mindset that heated soup, fueled escape attempts like the Great Escape. Ingenuity scales, Once you prove you can bend the system, you start testing the limits. It's easy to focus on battles, on generals, on strategy maps, but survival stories reveal something deeper. War compresses humanity into extremes, and in those extremes, creativity becomes currency. The immersion heater wasn't dramatic. It didn't explode, it didn't storm a gate. It quietly boiled water, night after night, under watchtowers, without smoke, without fire. Imagine holding 2 razor blades in your hand. Imagine risking shock. Imagine knowing you could be punished, and still choosing to try, because warmth meant hope, because cooked food meant control, because survival wasn't just about breathing, it was about living. The Nazis built camps to contain bodies, but they couldn't contain physics. They couldn't extinguish ingenuity, and they never fully stopped the quiet hum of resistance heating. History remembers the battles, But sometimes the most powerful acts of resistance are the ones that don't burn at all. If this changed how you see survival in the Second World War, stay with us. There are more hidden innovations, more forgotten tactics, and more stories where science met desperation and won. Because sometimes the smallest spark never needed a flame.